theme here. One of my subscribers, Diane, was asking me about EV battery chemistry, so I thought I'd make a quick video and talk about the different battery formats and chemistries used in the EVs today. So all the pure EV makers seem to be using cylindrical cells, including Tesla, Rivian, and Lucid. These provide a high safety because each cell is encased in a cylinder of metal and they're individually fused for safety. There's usually worse repairability with cylindrical cells because they have to be arranged in the pack, and usually there's foam injected between the cells to keep them from rubbing together and for any kind of thermal mitigation. They also can be more expensive to manufacture because of the metal encasing each cell. Now, cylindrical cells are generally high performance, but the cooling is more complicated. You have to wrap the cooling lines around the cell or cool from the top or bottom. Now, pouch cells, they're like plastic bags filled with lithium polymer, and they're used by all the legacy auto manufacturers. Now, there's going to be easier repairability because they're arranging them in modules. They're putting these pouches into aluminum boxes with cooling plates for separation. They're seen as less durable because they're not encased in metal themselves. They're relying on the manufacturing process of the containers that they're in to make the batteries safe. And there's more chance for safety issues. We've seen with the Chevy Bolt that uses pouch cells that if there's a manufacturing defect in the cell, then it could cause a problem with the pack. Now, pouch cells are less expensive to manufacture. It seems like there's some efficiencies in the supply chain. There's one other type, it's a prismatic cell, which is kind of like a rectangular box with a aluminum or steel thin outside structure, and those are used for LFP only. So now let's talk about the different chemistries. So in a Model 3 Performance, you're using a Panasonic NCM nickel cobalt manganese cell, a 2170 cylinder cell. Now, these, NCM chemistry is it's volatile, so if the cell gets ruptured, it can have a thermal overload, it can start a fire. So there has to be protection in the pack as well as inside each cell. Now, these NCM cells are generally higher capacity. They cost a little more to manufacture. They have a high charge rate, like the Model 3 Performance can charge at 250 kilowatts. And they have a fast discharge rate. So they allow for performance EVs, like the Model 3 Performance can do 60 in 3.1 seconds. Now, if you look at the Model 3 standard range, rear-wheel drive, those use LFP cells. So these cells are safer. You can charge to 100%, possibly longer lasting. There's less capacity, they're less energy dense, which means more weight. Now, they're less costly, so the entry-level Model 3 can use them. They're slower charging, 170 kilowatt maximum, and slower discharge. So you're not going to see LFP batteries in a performance model car. The Model 3 standard range rear-wheel drive does 60 in 5.8 seconds. LFP can also be worse in cold weather. So, especially so in the single motor rear-wheel drive Tesla Model 3 standard range, because in the cold weather, the battery cells have to be warmed up above freezing before they can charge. And the way Tesla does this and others is to use the motors, electric motors, to generate resistive heat to warm the battery pack up so it can start charging. So the LFP used in these standard range models may not perform as well in cold weather. Now let's talk a little bit about Rivian. So they're using like a Samsung 2170 cell. We think 50 series. Those are in the large pack. So this has high capacity, fast charge rates over 200 kilowatts, and high discharge. In the quad motor, you can do 60 in 3 seconds. Now Rivian just released the Max Pack. Now the Max Pack has the same number of cells as the large pack. It's just using a different chemistry. People are either thinking it's a Samsung 53G cell or maybe even an LG. This has a higher capacity, but it'll have a slightly slower charge rate, as we've seen with some of the early tests, and a slower discharge rate. That's why you can't order the Max Pack in the quad motor Rivian, but you can order it in the dual motor Performance. It's slightly slower, 3.5 seconds to 60, which is still really fast. All right, there you go. There's a quick rundown of the different types of cells and chemistries that are used in EVs today. Remember to like and subscribe for more videos on Wi-Fi, tech products, Rivian, and Tesla.